magnesium ribbon. Today we are going to calculate the molar or the atomic mass of magnesium ribbon using molar gas volumes. So magnesium is very light. So I am going to take a piece of 10 centimeters and then I'm going to weigh this 10 centimeters accurately on my top pan balance. I'm switching it on and then I'm getting my mass. You can see that the mass of the magnesium is 0.18 grams. The next step is I am going to take this piece of magnesium and then I am going to cut it in two pieces of 0.5 centimeters, two pieces of 1 centimeter, two pieces of 1.5 centimeters, and then two pieces of 2 centimeters. How will I find the weight of this? Very easy. By dividing my 10 centimeter piece of 0.18 grams into 10, which will give me an answer of 0.018 per centimeter, which means a piece of 0.5 centimeter will give me an answer of 0.009 centimeters. So my 0.5 centimeter of length will have a mass of 0.009. Right. My next step involves a dilute solution of hydrochloric acid. I am going to pour about 25 cubic centimeter of hydrochloric acid inside my measuring cylinder. Please don't inhale the hydrochloric acid, it's corrosive. And when it makes contact with your skin, please immediately wash it with lukewarm soap water. We all know that magnesium and hydrogen gas, a hydrochloric acid, will give us magnesium chloride and hydrogen. And this is the hydrogen that we are going to capture inside my syringe. And we are going to measure the volume of this hydrogen to use with our standard volume from Avogadro, which is 24 cubic decimeters under standard conditions. So I'm putting now my little piece of magnesium inside and I'm closing immediately. You will see the syringe moved up until this mark. This syringe has markings and is calibrated in 5. So you can see that it's 5, 10, between 10 and 15, which makes it about 13.5 cubic centimeters. Right. I will do this again just to get an average. Don't forget, when you take it out, to just put your syringe to the 0 position again. Once I've completed my whole table, I will see exactly my average amount of hydrogen that was produced from each length of ribbon of magnesium. My next step is to plot down my graph of hydrogen gas against my mass of magnesium. You will clearly see that I'm going to use these values against these values, right? So it's 0.009 would be somewhere about here, and then 13.5 will be somewhere about here, where I make my first little cross. 0.018 will be about here. No, it will be about here against 16.5. 0.024 which will be about here. Please note that you should use a ruler for this and a pencil for this, and then your pencil should be very sharp in order to minimize the amount of errors that you make in drawing your graph. Also note that the total space that you take for your graph should cover 3/4 of the total grid that you have in front of you. So as you go along, you will see that you will form a straight line. Let's just say your points was all the way up to there. You know that you must draw a straight line. What you will draw, we call a line of best fit. You will not go connecting all these dots one by one, but you will draw a line that will best fit all of your values. This line will have the same amount of points above your line as underneath the line and do not have to touch all of your points. The more accurate you worked, the more your line will face a straight line value. So in this case, my straight line will basically go through here. As you can see, 2 of my points are slightly above my line, where 2 of my points is below the line, where 1 of my points is exactly on the line. Also note that my line is going through the origin, my first point being a 0 and 0 point, which means that if I don't put any magnesium strip into my acid, then no gas will evolve. That's always a very reliable result, the 0, 0 point, the point of our origin. From here, I can now calculate the amount, the mass, of the magnesium that will cause an amount of 24 cubic centimeters of gas to evolve. If I look at this, 24, it's going to be a value of about 0.025. Now that we have all of our information, we can start calculating our values. We know now that it takes such amount of grams of magnesium to give us about 24 cubic centimeters of hydrogen gas. Using our molar gas volume formula, amounts of moles equals my volume divided by my Avogadro's volume, which is always 24.1 at RTP standards. Which means I'm going to take my 24 cubic centimeters, I'm going to divide it by 24 cubic decimeters, and I'm going to change that cubic decimeters to cubic centimeters by multiplying it again by 1,000. So let's do this calculation. I have 24, which I now divide by 24 times 1,000. And that gives me 0.001 moles. So this basically means that 0.001 moles of hydrogen gas were formed from 0.025 grams of magnesium ribbon. Next, I'm going to show you in my formula of magnesium, when I add my hydrochloric acid, it formed magnesium chloride and hydrogen. You will see that all of this is in the ratio of 1 to 1 to 1, as it is balanced as it is. Like that. Which means my amount of moles of my magnesium is the same as the amount of moles of hydrogen gas that formed. So which means my molar relations will be the same. Which means my molar formula, molecular formula, will be my mass divided by the amount of moles. My mass which is 0.025 grams, and the amount of moles, which is 0.01. And if I do that calculation, I will arrive at my answer. Which is 25. If I now look at the periodic table, at the molecular value of magnesium, you will see that we are not so far off of the correct value.